everybody, thank you so much for having me on the Activate session of 2022 with my presentation of Dialectic and the narrative of data-driven search results, where basically I want to show some of our ideas of how in our projects we want to balance the search effectiveness with the optimization of those results, adhering and catering to the business needs and strategies. So I'm looking very much forward to not only sharing some of our experiences and practices of dealing with web search initiatives, but also to learn a lot from all the other participants of this event. And naturally hope there will be lots of questions and suggestions as a result of that small presentation. So maybe first a bit of introduction on myself. My name is Winkler. My background is in economics and business administration. I made my master's degree with emphasis in finance, marketing, and project management at the University of Francisco de Vitoria, Madrid, Spain. My PhD at the Universidad Latina de Panama, with emphasis on applied business process automations within the financial industry. So basically looking at frameworks for finance automations as well as measurement frameworks in LATAM for the financial industry. Professionally, I apply what I've learned at CSS Commerce, where I work as the VP of Delivery. At CSS Commerce, we are implementing mission-critical solutions in e-commerce, B2B, but also B2C, mainly B2B, featuring things like e-commerce naturally, but everything that drives and fuels e-commerce, including search. But also things like product information management, PIM, databases, database engineering, integrations, and business intelligence. At NSI, I'm working as a partner and director for business process automation solutions and RPA, robotic process automations throughout the region of LATAM and the United States. And at the Association of Business Process Management Professionals, the APPMP, I work as a VP for chapter services. What we do here basically is looking at spreading the knowledge and wisdom around business process automations. Additionally, we, whenever there's a chance, teach and give classes at UNIR, a university in Spain, Aden, that's a university in Panama. So the case that we wanted to highlight today is Mark's Plumbing. So Mark's is one of the major B2B and B2C plumbing suppliers in the United States, where we face the impressive challenge of having to deal search-wise with over 1 million products online, where we faced what you can imagine being the typical challenges of slow loading speeds and querying speeds as well. So that basically the results that we got as a result of a query were either suboptimal, the rendering of them were slow, but also we got a whole bunch of null results. So basically a big business and a typical issue big business, and I'm sure many of you face as well, having loads and loads of product variety and quantities online, where we have to make sure that those things load speedy, but also that the search results are as exact as possible and also drive business, right? So things like null results are of course a big no-go there. So that's what we faced, and where we applied the search optimization project that we are showcasing today. So in that sense, what we established is goal number 1, where we want to first embed and then extend a unified search engine that funnels all the activities, be it here in typing a search term in, while typing, getting predictive search results with an image, a short description, having the search engine taking over and leveraging the layered navigation. So underneath, of course, we have our filters, and once you click an option, either hitting enter here, selecting an image or selecting a description, going through the layered navigation, going to either the product detail page if you selected a single SKU, or to the product listing page, so that we have that all unified and centralized in a single engine. So we did that, and also with that eliminate and nullify null research, so that null research become edge cases, rather than the norm what we had before. And then also making sure that the response times in executing the query and rendering the pages as a result of that query in mere seconds or fractions of a second. So that worked very well and helped us to optimize basically the base layer of goal number one, search basics, right? So repeating, funneling all the different entry points so that we have a single, in quotes, source of truth, or a single entry point for everything that is search related, and then optimize that engine in a way that whatever we spit out as a result then is optimized to respond in a fraction of a second or a couple of seconds depending on the query, and extend that to the page navigation as well. So before jumping into the aspects of goal number two, maybe a couple of words of our choice of the term dialectic and narrative. As you may have seen at the very beginning of the presentation, the core of what we are aiming at implementing such solutions is to achieve a balance between the term coverage, the logic of the results, but also the business needs and business strategies. So many of you have come across making the most out of what you see here, maybe on the screen, the TF IDF, the term frequency, the inverse document frequency, so that the logical outcome is as optimized as it can be, as optimized as possible, but leaving space open in our algorithms to achieve inputs that balance that logical results out with the business drivers. So I will show in a couple of slides what that means, but basically finding a balance between those two components. So that also entails that we needed to find, and we have implemented, use interfaces for the end user to administrate those components, those variables, to create a balance for the strategy by SKU, by category. You may get the picture already if you listen to the components we channel into the balance, into the algorithm. So that if you really want to drive, besides or within the confines of a good search results, certain SKUs, certain categories, certain vendors, or other variables, then that you have an entry point to do that. In other words, we strove to incorporate variables that are relevant to the document itself, so to the search term, but also to the business requirements on different levels. And that is not only what you see after rendering, usually in, hey, if somebody buys that, they usually end up buying those other things in addition, or as a replacement item, but also prior to that, so that when we render the search result, that part of that search result is already a SKU into the direction that the business wants to go in. Be that by SKU, be that by category, vendor, or some other attributes. And the challenge then was basically to introduce placeholders in the functions, in the algorithms, so that the external sources can be taken into account, and that they then have a weight that you will see in the next slide to render an interior result that takes both aspects into account. The logic aspect you see here on the right, but also the business aspect you see here on the left. On render, and not necessarily post render as an option to buy different alternatives. So how does it look like on a very abstract, very summarized level? We basically do two things. We combine the logical matching mechanism from the syntaxes of the search term with a weightage distribution that is enriched by internal and external attributes. So here, for example, you have internal attributes, normal things that you come across all the time, like a number of an item number, maybe high frequency sales sold items, a UPC number. So different attributes you already internally may carry somewhere in an e-commerce system, and you decide to become part of an equation that takes also into account external attributes that may be interesting for folks that want to incorporate things like big data, or like we did, Google Analytics aspects into the weightage and into the factors or sums, depending on how you establish the weightage control, that then in combination gives you back a result that makes sure that the logical coverage is assured, but also within that vector, within that array of a result, then you can either push or also rest information or weightage to certain SKUs, certain vendors, as you see fit from a strategy point of view in your business. So in a nutshell, we did 3 things: assure that we have, of course, the IDFTF relevancy and the matching ironed out, but then also adapt the outcome with internal and external attributes. More importantly, that the way we summarize that, then it becomes a formula that can be maintained by the end user, so that the end user can also decide on things like weightage and polarity. So for example, if we have a slow selling item identified over some time series from an aggregate like in Google Analytics, we take that into account and then can assure that if something sells slowly, it becomes something we boost in polarity and weightage, so that if we have a match here on IDFTF, there becomes then that we get a list where this resulting slow selling item is higher on the ranking than maybe a better selling item, if that would be one of the strategies to get rid of slow or dead inventory, slow moving or dead inventory. And that, on the other hand, basically defines our goal number 2, where we extend the Google Analytics API, in that case, to the search results. We fed that in addition to local e-commerce KPIs. And with that, we produce the sequence of appearance of the different search results, either on a search result and click, or on a search result forecast or predictive search, to make sure that those search results then align with the logic, of course, and the speed and everything we talked about before, but also they are skewed in a positive way, right, with the business requirements. So interestingly, here in goal number 3, we see that we didn't limit the scope of the search optimization on the input side of things to optimize the search results with logic and business needs, but also store all the keystrokes, now that we have a unified engine, into a database that allows for continuous improvement. So that if somebody navigates, so that we expand the layered navigation, for example, or start typing and creating predictive search results, or clicking in on the product level details or the PDP, the product detail page, everything gets stored in a data repository that then we can use in order to drive continuous improvement on the entire site. And that is basically what we ended up doing exactly. So we took the information out of the database and applied data mining in order to see, now that we not only know like on a Google Analytics level of things, the keystrokes and what people do, but also can tie that to a specific user and user ID of what the clicks and the path to the shopping cart, to the checkout was, and how many retries somebody needed in order to decide on a certain purchase and shopping cart. So doing that on a continuous level allows you to, within a time frame and over a larger span of time, identify trends and inefficiencies, and also shorten the time to yes and time to cash cycle and optimize the page with that. So we use that information in order to drive not only better results and faster results, but also to improve the shopping experience altogether. That of course was a very fast, a very abstract example of a search project and a couple of methods we apply at CSS Commerce. Hopefully it was something you find useful for your initiative, for your projects, and I very much look forward to your questions, your feedback, and get in touch with you soon. Thank you so much and have a great day. Thank you.